Hi guys, this is AS Chemistry, Concentration and Titration. Question 8. Citric acid is found in lemon juice. What is the volume of 0.4 mole per dm cube sodium hydroxide solution required to neutralize a solution containing 0.005 moles of citric acid? So, looking at the structure of citric acid, we have 1, 2, and 3 moles of COOH present, which means 1 mole of citric acid will react with 3 moles of NaOH because it has got 3 acidic groups present. Now, we have moles of citric acid, which is 0.005. So, moles of NaOH would be 3 into 0.05 because 3 moles of NaOH are needed to react with the given citric acid. This gives us a mole value for NaOH to be 0.015 moles. So now that we know the moles of NaOH required and we know the concentration of NaOH, we can calculate the volume of NaOH. How? First, we use the concentration. 0.4 moles are present in 1000 cm cube of the solution. So 0.015 moles, the moles which are needed, will be present in what volume of the solution? So we can calculate this to be 0.015 divided by 0.4 multiplied by 1000, giving us a value of 37.50 cm cube of NaOH, making option C the correct option for this question. Question 9. A white powder is known to be a mixture of magnesium oxide and aluminum oxide. 100 cm cube of 2 mole per dm cube NaOH is just sufficient to cause the aluminum oxide in X grams of the mixture to dissolve. The reaction occurring is given. 800 cm cube of 2 mole per dm cube HCl is just sufficient to cause all the oxides in X grams of the mixture to dissolve. The reactions occurring are, the first reaction is for aluminum oxide and the second one is for magnesium oxide. How many moles of each oxide are present in X grams of the mixture? Okay, so let's take this one by one. The first step would be to find out the moles of NaOH that reacts with aluminum oxide. So the concentration given is 2 mole per dm cube. That means 2 moles in 1000 cm cube. How many moles would be present in 100 cm cube? So this would be 100 upon 1000 into 2. So this gives us a value of 0.2 moles. So according to the given equation, if the moles of NaOH is 0.2, molar ratio of Al2O3 is to OH negative ions is 1 is to 2. So that makes moles of Al2O3 as 0.1, which means the moles of Al2O3 present in the mixture are 0.1 moles. Okay, this completes step 1. Step 2. Now we have 800 cm cube of HCl that completely reacts with all the oxides present. So in total, we have 6 moles of HCl reacting with Al2O3. So Al2O3 is 0.1 mole. So HCl that is required to neutralize Al2O3 is 0.6 moles because the molar ratio of Al2O3 is to H positive ions is 1 is to 6. So now we have obtained the value of, or rather the moles of HCl required to neutralize Al2O3, and we use the given concentration and volume, which is 2 mole per dm cube concentration of HCl and 800 cm cube, to calculate the total moles that are needed to react with both the oxides. So 2 moles are present in 1000 cm cube. How many moles would be present in 800 cm cube? So this would be 800 upon 1000 into 2, which gives us a value of 1.6 moles. So the total number of moles of acid that reacts is 1.6 moles, and the moles of acid that reacts with Al2O3 is 0.6 moles. So the moles of acid that reacts with MgO would be 1.6 minus 0.6, which gives us 1.0 moles of HCl reacting with magnesium oxide. So, how many moles of each oxide are present in X grams of the mixture? So, if the moles of HCl that reacts with MgO is 1.0 moles and the molar ratio of MgO is to H positive ion is 1 is to 2, that means moles of MgO would be half of 1.0, which gives us 0 0.5 moles of MgO. So now we have 0 0.5 moles of MgO which are present in two options, and we have 0 0.1 mole of Al2O3 which is only present in one option. This makes option D the correct option for this question. Question 10. A piece of rock has a mass of 2 grams. It contains calcium carbonate but no other basic substances. It neutralizes exactly 36 cm cube of 0 0.5 mole per dm cube hydrochloric acid. What is the percentage of calcium carbonate in 2 gram piece of rock? So the first thing we need to do is write the equation for the reaction of calcium carbonate with HCl. So that would be CaCO3 plus 2 moles of HCl producing CaCl2 plus CO2 plus H2O. So this gives us a molar ratio of 1 mole of calcium carbonate reacting with 2 moles of HCl. The next step is calculating the MR of CaCO3, which turns out to be 100.1. Now, the third step is to calculate the moles of HCl that reacts. So, the given concentration is 0 0.5 moles in 1000 cm cube. How many moles would be present in 36 cm cube? So, this calculation is 36 upon 1000 into 0 0.5, which gives us a value of 0.018 moles of HCl. Now we have the moles of HCl present, which is 0.018. So moles of calcium carbonate will be half of 0.018, which will give us a value of 0.009. 0.009 moles. Now we have moles of calcium carbonate. We have MR of calcium carbonate. We can calculate the mass of calcium carbonate. Mass equals moles into MR, which is 0.009 into 100.1. This gives us a value for mass to be 0.900 grams. So finally, we have the mass of calcium carbonate present in the rock, which is 0.900. Mass of the rock is 2 grams. So in order to calculate the percentage, 0.9 upon 2 into 100 gives us a percentage value of 45.0%. So this makes option B the correct option for this question. Question 11. Sodium hydroxide neutralizes acid and the molar ratio of this reaction is 1 is to 1. In a 11,000 dm cube sample of an aqueous solution, the concentration of acid is 1.26 into 10 to the power of minus 3 mole per dm cube. Which mass of solid sodium hydroxide neutralizes the acid? So first we need to find out the moles of acid. So the given value for concentration is 1.26 into 10 to the power of minus 3 moles in 1 dm cube. How many moles would be present in 11,000 dm cube? So this would be 11,000 upon 1 into 1.26 into 10 to the power of minus 3. This gives us a mole value of 13.86 moles of acid. Now, since moles of acid and moles of base are the same, moles of NaOH is equal to 13.86 moles. MR of NaOH is 40, 23 plus 16. Therefore, mass of NaOH would be moles into Mr, which will be 13.86 multiplied by 40, giving us a mass of 554.4 grams, making option D the correct option for this question. Question 12. In this question, it should be assumed that ammonium carbonate hydrated dissolves in water without causing an increase in volume. Which mass of hydrated ammonium carbonate should be added to 800 cm cube of water to form a zero point 0.1 mole per dm cube solution of ammonium ions? So we have the concentration of ammonium ions present, which is zero point 0.1 mole per dm cube, and the volume of water that should be added that it should be added to, that is 800 cm cube. So first we calculate the moles of ammonium ions present. So that would be zero point 0.1 mole in 1000 cm cube. How many moles would be present in 800 cm cube? So this would be 800 upon 1000 into zero point 0.1, which gives us a mole value of 0.08 moles. Next, we need to write the equation of dissolving of NH4 twice CO3 dot H2O in water to produce 2 moles of ammonium ions, because there are 2 moles of ammonium ions present in the salt, plus 1 mole of carbonate ion. So, the molar ratio of the reaction of ammonium ions and ammonium carbonate is 2 is to 1. Since we obtained a value of 0.08 moles of ammonium ions, the moles of salt present would be half of that. So, half of 0.08 gives us 0.04 moles of salt. The next thing is to calculate the MR of this salt. So, MR of this salt is ammonium, two ammonium ions, one carbonate ion, and one water molecule, giving us a total mass of 114 as the MR. So now we have the moles and we have the MR. We will calculate the mass. Mass is equal to moles into MR, which is equal to 0.04 moles into MR, which is 114, giving us a mass value of 4.56 grams, making option A the correct option for this question. Question 13. A 3.7 gram sample of copper carbonate CuCO3 is added to 25 cm cube of 2 mole per dm cube hydrochloric acid. Which volume of gas is produced under room conditions? So when these two reagents react, the products are CuCl2, which is aqueous, plus H2O, which is a liquid, plus CO2 gas. So the molar ratio of copper carbonate is to carbon dioxide, which is the gas, is 1 is to 1. So we have mass of copper carbonate present, which is 3.7 grams, and we can calculate the MR of copper carbonate, which would be AR of copper is 63.5, for carbon it is 12, for oxygen it is 16 into 3, which is 48, giving us a total mass of 123.5 as the MR of copper carbonate. So moles of copper carbonate would be 3.7 divided by 123.5. So this will give us a mole value of 0.03 moles. Now, since the molar ratio for copper is to carbon dioxide is 1 is to 1, so the moles of carbon dioxide would be 0.03 moles as well. Now we need to find out the volume of gas. 1 mole of any gas occupies a volume of 24 dm cube. So 0.03 moles of carbon dioxide that has been produced will occupy a volume of 0.03 upon 1 into 24, giving us a volume of zero point 0.6 dm cube, making option A the correct option for this question. Now, be careful. The volume and concentration of hydrochloric acid given may put you off and you start calculating the moles of hydrochloric acid. But here, the mass of copper carbonate can be converted into moles easily. And since the moles of copper carbonate is the same as moles of carbon dioxide, this question can more easily be solved by considering the mass of copper carbonate instead of first calculating the moles of HCl and then doing the calculation moving forward. So, using the mass of copper carbonate, the volume of CO2 produced turns out to be zero point 0.6, and option A has this value present, so option A is the correct option.